Hello Year 9, this is lesson 3 in the Electricity and Magnetism booklet. We finished off last time with this diagram. It's a simple series circuit. It's got a battery and the battery has a positive end and a negative end, and so that means that current flows, in this case clockwise. It flows through the switch that has been closed. It flows through the ammeter, which gives us a current reading of 0.90 amps. It then flows through the bulb, causing the filament to heat up and light the bulb, and then it eventually makes its way back to the battery again. Now, notice that the ammeter is placed in the main circuit. Look at all these arrows again. They're showing the main circuit, the flow of current. The ammeter is in the main circuit. In fact, all the components here are in the main circuit. They are placed in something called series. Now, that is not the case when we add a voltmeter. And so this is the start of lesson 3 now. You can see straight away that the voltmeter is not in the main body of the circuit. Okay, it's actually surrounding a component. In this case, it's surrounding the battery. We say that it's been placed in parallel. Okay, now what I'd like you to do is to generate this circuit with the following equipment. So the first thing that we do is we type into Google FET circuit. Circuit construction kit. So let's put that in. Circuit construction kit's that one, I think. Skip the intro, go into the lab. And this is where we start to generate this circuit, okay? So bring out the battery. Oh, I'm going to turn off the current, this one here, show current, no. So there's the battery, then there's a wire. Lengthen the wire. Then another wire. All the way down like so. I think we've got another wire then. Followed by a switch, followed by another piece of wire, followed by an ammeter, measures current, followed by another piece of wire, followed by more wire, followed by a bulb. Link up the bulb, final piece of wire. Now the current isn't flowing at the moment because the switch is open. If I were to close the switch, there it is, then that means that we've got 0.90 amps of current flowing and the bulb, as you've seen, has lit up. Now what we do is we add in our voltmeter. Now it's not going to be in the main body of the circuit. Get our voltmeter. We're going to place it around a component. In this case, we're going to put it around the battery. And we should get a reading. And there it is. It's 9 volts. So if we go back here, write in the voltage. So you put in here that it is 9.00 volts. Add that into the diagram. And then it says, using your knowledge of circuit symbols, draw out this circuit. So here's the battery. That's the positive end, that's the negative end. Remember, you should be using a ruler to construct this. I unfortunately am having difficulty using the ruler with this piece of software. We've got a switch that is currently closed. We then have an ammeter, that's a circle with an A inside it. I'd be using like a 2p or 5p coin, 1p coin, pound coin, something that's circular. Then what we have is our bulb. That's a circle with a full cross going across it. And then we link that up back to the battery. There's our main simple series circuit. What I now do is I add in my voltmeter. Circle with a V inside it. It's not part of the main circuit. It is surrounding another component. You could have put it around the bulb if you wanted to, but in just this example, we put it around the battery. And we say that that is in parallel. So this is really important. We say that the voltmeter is placed around a component. We say it has been placed in parallel. So if we move on, we've added in information about an ammeter and a voltmeter. Now we can add in a little bit more. I'm going to read this left-hand sentences. This is placed around a component. It is placed in parallel. That must be a voltmeter. So I'm going to colour that in yellow because that should be being placed inside that circle. And then the other sentences, this is placed into the main body of the circuit. It's placed in series. That should be going into, you should be writing this into this circle here. Okay. We are now going to look at the two basic types of electric circuit, series and parallel. The circuit below is a series circuit. What I'd like you to do is to go to FET and construct this circuit here. Don't forget to include a switch that is open. And then what I would like you to do is answer questions 1 to 5. I shall come back and give you the answers in a moment, but I'd like you to construct the circuit yourself. Having constructed this basic simple series circuit, these are the answers that you should get. What happens when the switch is closed? Bulbs A and B light up. What happens to bulb B when bulb A is removed? Bulb B goes out. What happens to bulb A? This is question 3. When bulb B is removed? Bulb A goes out. Name one situation where you might see this circuit. Difficult one, that. You'll see it in a torch, possibly, or Christmas tree lights. And the problem is, if one bulb in Christmas tree lights blows, they all go out. So that's not a useful circuit. Now, the other thing, of course, is what happens to the brightness if we add another bulb? All the bulbs get dimmer. This is not a very good circuit. Okay? And so here we go. Question 1. Yeah, you turn on the switch on and both bulbs light up. Remove one bulb, the other bulb goes out. That's question 2 and 3. Question 4, lovely Christmas tree lights there, but if one blows or if one is removed, they all go out. Not a good circuit. And question 5, we've got 2 bulbs here. They're nice and bright. But then if you add another bulb, they get dimmer. That's not good. Okay? We have seen that a series circuit is not very useful. There is another type of circuit you could create that is much better. When one of the 2 bulbs in the circuit does not work or is unscrewed, the other one stays lit. Try to create this circuit using only the following pieces of equipment. 2 batteries, 2 bulbs, a switch, and as many wires as you want. What we will do is we will look at this in our next lesson. So well done today, end of lesson 3.